and welcome to this technical domain session as part of the buildingSMART International Standards Summit, Valencia 2024. Thank you for joining. My name is Andre, and I will be your moderator today. Today's session is titled Test Dataset Validation and Use Case Confirmation. The speaker for this session is Greg Schleusner, Director of Design Technology at HOK. This session is scheduled to last 90 minutes, including time for questions at the end. This session is being recorded, and it's a hybrid event. The recording will be made available in the replay section. I would also like to bring to your attention that buildingSMART is committed to ensuring that participation in the development of standards is unrestricted, and the process for their adoption is transparent, and standards that are developed do not favor any particular provider and are open, non-binding, and accessible at all. Now I would like to hand over to Greg.
Okay, thanks everybody. So today's session, we're going to step back a little bit. So I'll walk you through progress we've talked about in previous meetings and technical discussions, and then I'll maybe explain the point we're at in IFC5 development, and then the reason to have a discussion about the sample data set is one of the things we've quickly found when we're trying to do experiments is we don't have a rich enough, broad enough sample. So really what I'm going to try to put in front of you is a starting point to do exactly that, and try to elicit from the room all the stuff that looks like what I'm showing you, but is not what I'm showing you, so we can start to catalog all the stuff we need to put in the data set that would validate building, infra, interplay on a big campus, little campus, all these sort of things. And this is there are good data sets out there, but we don't have one that tries to push what we're trying to do with IFC5, so that's why we're having this discussion. So I'll just walk you through, if you haven't seen some of these slides, the sort of breadth of this discussion started with something like this. Oh, that's so shiny, like a piano. The idea that what are we solving for IFC in IFC5? Well, we take something as simple as a light fixture. Imagine this light fixture is either in a building or along a roadway. It does not matter. You can replace these sort of roles, but a designer or an architect might specify a location, a lighting designer specify performance, the electrical engineer might, and this can vary by your place in the world, but the idea that these are the things that different parts of a group of people care about. A contractor might want to try to procure the products that actually are these light fixtures, and then if this isn't actually in maintenance, then you'd want to maintain them. And the fact that depending on the kind of project, whether it's a built facility doing renovations, these could all be happening at the same time multiple times. So the point of from this perspective, IFC5 was, okay, how do we enable simultaneous ownership, not individual ownership, which IFC enables today? And a simple example is around something as simple as a wall, where a wall looks different to different groups of people. So that, from a structural engineer standpoint, they might just care about the sort of center line plus this header. The door to a architect might just look like a door, but the door to a low voltage engineer might look like the control system and the control network. These are all not things they're possible to model in IFC, but they're not stuff we've decided and helped people understand how to do this again at the same time. One-off, this is easy, having this exist at the same time. Or you want to have different representations of the same spatial geometry. We have this concept, but they're not well defined. And then we have this much larger issue where, and the word assembly and scene can be thrown away at this point. These are slightly older slides, but when you put these things together, there's so many different views of this data that there's no one view. There's no one owner. And so this is generally the problem we're looking to solve. So we had this initial list, which is what are all the requests of IFC in the future? And this is just a list. It's not necessarily saying there's a priority for any of the things. I think one of the, at least my observation in the last day, we tend to skip construction in a lot of our conversations. We go from design to asset management, which construction is an interesting one because data is half done, half created, or half designed, half built. So the time element of actually the state of the data is an interesting one, and it'll come into a discussion. But also, if we talk about, Clive mentioned on stage, machine-to-machine data, if we think about what's coming or wants to come, I made sure Ken was in the room on both of them. Kajima is here, but the idea that if you want to use robotics and the data wants to be helpful for it, what do we need to be thinking about? Not necessarily a conversation today, but it's a what does actual machine-to-machine data look like in other things besides design to assets, which is often the way it gets talked about. Feel free to raise your hand, make notes. You're going to get very bored of my voice if it's just me. So this was we used whiteboards in the previous sessions. I like drawing these things out. We don't have one here today, but that's fine. This was from Oslo, where we started to say how we would just deconstruct an existing IFC file. Not important for today's discussion. And then Rome, we did, which was its predecessor. Excuse me. We went through and captured all the sort of design criteria that people thought were important. We haven't ranked them. We haven't said if they're all in or not, but we went through and captured the criteria. I don't know why I took all these from the side when we were done with the session. I couldn't possibly look at these things straight on, so they're all askew. I don't know, maybe it's the photographer in me that wanted to draw your eye across the page. Who knows? We don't have to go through all these, but like small changes. It's always good to write these things down, and I'm glad I captured these things because they always come back to be part of the discussion. Distributed, searchable, extensible, automatable. This one is well, actually, I'm reminded that in this session, I was late. I didn't oversleep, but I was quite disheveled in this session. But either way, the writing reflects that. But no monolithic files, less complex, change that's easy and stable, implementation speed. And then from a dev perspective, APIs, separation of data from the technology we used. I think you get the point. A lot of these are around not just having the standard, but making sure the standard works for the things people want to do with it, which is a very hard thing to plan for, right? So this is why my job in this moving forward, I was introduced, but I'm a building architect by training, technologist by skill set, can't program anything in a computer besides ChatGPT. So I'm a functionary program manager here. I'm not building any of these things. So my job is to make sure we get the requirements right, we plan it right, and then I have to lean on other people that are much smarter than me when it comes to talking to a machine to implement these things. Apologize for the out of order conversation. The fact that we would lean more heavily on data dictionaries, specifically BSDE, a lot of our definitions would move away from the data sets. I think these last ones were really just around how we would start to construct stuff. And then we had sort of terminology that started to make its way in. So we're not going to go through the most detailed version of this story today, but the main story is the idea that if you want to distribute ownership, have multiple representations, well, that's magic. Maybe there's automations in these slides to keep me from talking too long. That really what we need to do is be able to break a singular definition into a bunch of definitions and have them share this thing called an entity, which is an identifier. And that way you could assemble different pieces of data, and those don't have to be in the same, from the same author, same application. Yeah, of course, I gave myself animations that I forgot about. This is what happens. You reuse slides over and over and over again. But the idea here is the roadmap to do this is pretty straightforward. There was some discussions we've got pretty far on what components look like. The place that we're sort of in a technical mulling is if this is really straightforward when it comes to if everything was unique, what everybody knows, no building, no infra project, not everything is unique. We have typical data. This is the terminology we're trying to sort of move away from types, because type means something to somebody. So the idea that there's typical information about a light fixture, well, it's shared across all these light fixtures, or these pieces of furniture, or the windows, or signage, and that these things, I'll keep going back here. How do you assemble those in such a way that I can have typical data? This is a harder problem that we're working through right now. But what we found in going through that, and I'll just pause for a second, this was an illustration of that what you end up doing in a system like this, instead of having a singular definition, what you do is you collect the things that are important to communicate. So on the stage yesterday, Clive that said things like, communicate the pieces of information that are important to the consumer and not more. This is actually something Julian said as well. These concepts that you pick and choose the data that's shared, that we don't have to have, we don't have to solve contractual boundaries to have transactions across parties because the system doesn't require live access to the data. These are sort of parts of the more technical aspects of this. To incorporate this on a white slide is impossible to read, but this was a notion that a design chair was some subset of that data. This location, property, and geometry was transmitted to a contractor. Contractor can add their own data to procure it. Those are two individual data sets. Some of them are shared, some of them are not, but you're talking about the same share. So this is the basics and mechanics of the way this is developing. I'm getting, am I getting a smile? Yes. Good. I always like reactions. You were moving towards a reaction, but I couldn't tell which one it was. So.
It was positive because this is the way we work in our platform. Lots of your requirements.
Yeah.
But not all.
Can I grab the mic? Oh, just in case we have more people. Yeah, I'll repeat it until we have more questions. But basically, there was a validation that the way the requirements are laid out look very much like they do in Sweden. What are you working for that?
I was previously a professor at KTH in IT construction. Now I'm a consultant and advisor for the Smart Built Environment program in Sweden for infrastructure.
Okay.
No, interoperability. And so I select the strategic projects for now.
Okay.
And finalizing a test bed for the whole built environment for life cycle stages.
So
based on the
you basically you've covered everything from research in buildings to research in construction, and now you're doing the whole life cycle.
Yes, and it's based on the PLS standard.
Okay.
Used by the Swedish Defense Material Administration. So it's a PLM standard that is now implemented in construction industry.
Yeah, what we find is a lot of systems that are deployed in software look like this because no system can own everything in reality. So it's realizing that our standard should enable this by default, if you will. This was just an example of showing how you might assemble different disparate information, disregard the sort of relationship graphics here, but the idea that this was in the context of doing carbon calculations right now, there's different information comes from different sources. So the idea is how do we start to assemble that? But you get the idea. So it's basically a lot of requirements, a good understanding of what the base idea is of this, the technical term is an any component system. But one of the things we start to look at is when you go to test these things, there's no good, I wouldn't even call it, it's not IFC data, it's just not, no one has tried to create a sample data set that captures these kind of requirements in them because we've never really manifest them in a way that are trying to be whole. So what I have started, and the reason that I'm saying started is very much because I want to get reactions, people to say what they need. We're recording this session, so I'm not going to take notes, but we'll go through and figure out from this what are the things we need in the sample data. So just to sort of start here, and unfortunately I didn't remember to bring my mouse today. So sort of envisioning the basics of a very claustrophobic site that brings together all the things we're starting to talk about. So tunnel, rail, alignment, buildings that are referenced to things. When I go into here, when we start to, I'm an architect by training, so I know the building domain a little bit more, but like when we start to look at the color coding here. So this little thing is supposed to be the controller or the motorized system on these doors. We have generic ways to modeling these things, but we've not fleshed out them in this new approach in IFC 5. I have a smoke exhaust system that is not, and again, this is all very, I'm explaining this to you so you get a notion of it, and I'm clumsy with Revit this way. And again, this is not meant to be the data set, it's an illustration of what this needs to start to contain. But I have let's say I have a smoke exhaust fan, I have a smoke exhaust sensor, it's a little green guy, and I have a facade element that is makeup air. So to walk through this, in the US, you do a Christmas tree test. It's the standard way of doing this. You light a live Christmas tree on fire and you envision it fills the smoke. You have to get the smoke out. If you were to go outside and do exactly what I was saying in the atrium and start blowing out the air, no one could get the doors open because there would be so much pressure. And so you have to provide makeup air, which alleviates the pressure. So this is a very complex system. They're never represented completely, but these are the kind of things we've envisioned that we need relationships for in IFC 5. So currently relationships are typically plumbing in IFC, but the idea that you can make these into systems, but there's different information that might be included in this sort of information. So I'll go with a quick tour and then we'll start to talk about what things people are interested in. Simple stuff, obviously we need doors, walls, and windows. We need the example I showed in the PowerPoint of to an a low voltage engineer, this control is the door. So those sort of things. From a structural standpoint, I have a facade mullion, and this particular one is connected to structure. So I need to make that differentiation. So that's on the architecture side, and if we go slightly further afield, thinking about the things that are coming, we have ports and waterways, we have water bodies. So we have a partially dug tunnel. That rail is fictional. We have a hole in the ground. Whether this is a hole is going to be the station or this is something else, I don't know. But the point is, we need to start to have a data set like this that actually describes not just the things. Things are probably pretty easy. It's what are the kinds of connections between large of the room, so I have to say products or systems or traditionally unconnected things like the placement of this building relative to the alignment. What are the important ways of talking about this, representing that in the data that are different across groups? So I see some nods. This is meant to be at this point, we'll go into an interactive mode because otherwise I'm just going to talk to you and go like this. It won't mean a whole lot. So does anybody want to raise their hand and we'll start capturing the mic of things they would like to see. And you don't have to build it yourself. We'll figure out how to get it built. You just have to describe what you think you need that has been missing from this discussion. If it's perfect, why are we here? Otherwise, it's a very easy conversation. Oh, man.
It's a question about one of the.
Hello. It's a question about one of the previous slides where you had the ID entity and then all the components. One of them was, for example, materials. And my question is, does that mean like now materials will be inherent part of the schema? Or can I link to other definitions of materials? Like a little bit like you have in the linked data context, I can link towards an ontology that is for building materials. Is there some kind of extension like that?
So that's a very good question. Dave is going to help me get some mouse plugged in my computer. Yeah, so this is a very interesting one. I might have the slides. Perfect, thank you. Let me open up another slide deck that I think I have. Not necessarily buildingSMART presentation, but materials is a super interesting one because everybody thinks they know something about materials, but I think no one knows anything about materials. Is it in this deck? It's always slide roulette with me. So I think the quick answer, I'm not going to find you a quick slide, it appears. One of the main requirements around this, let me try one more place. One of the main requirements is being able to link to different data sets. So this is an interesting question. So in buildingSMART, for everybody is aware, we have IFC, we had the linked data community come in and make IFC out. Turtle syntax, basically everything in IFC became a thing, a node, and I don't think in that world you have edges, or edges don't contain data. Well, it's not even this one either. But the requirements we got from different organizations is certainly IFC is not all data, full stop. So the sort of the design criteria for exactly this is that in this model, if you separate out the basic structure of the entities and components, anything can be a component, and you can have a payload that's any definition. So that's not to say that buildingSMART is going to make all those things, but you know what material properties does buildingSMART not address right now? Certainly doesn't touch visualization. Colors, yes, but there are plenty of good open representations of material information. So like Material X is the one that's becoming more popular in the film world. So the idea that we should be able to put them together, your applications still have to understand these representations. Like that is not free, right? If you have a sort of complex material representation or something like that, or a sort of set of carbon data, one of these components in that case probably is just a set of IDs and a URI. oh, here's the definition you're looking for. So it's a way of modeling subsets of data, and this is the distinction I would think in sort of the two polar ends of a monolithic file and the sort of linked data world, is linked data sort of treats everything the same. This is sort of saying, well, there are logical clusters of data that people care about. Like, so these components could be one property, they could be 10, but material might be one of those. And they don't have to be buildingSMART defined standards. So that's a fundamental concept that's part of this. That's a very long-winded definition. I was looking for this slide, I will never find it. Sorry.
So in this concept, can an entity be also part of an entity, or is it only separate blocks of entities describing?
Well, so the discussions, these are discussions not finalized. What we've sort of said is the entity wants to be the thing that has a name in the world. We've talked about needing different concepts though. Could be a typical entity, so like the typical light fixture, right? And not the instance of the light fixture might be an entity. And we would think we would have something, we would either call it an archetype or a prototype, which is the things light fixtures can be. And those look like products, right? My product definition that can be placed. What we have not figured out, well, we know, and these, I just saw those slides, so I could talk to those. I thought I just saw those slides. We know IFC today has these very, very complex set of collectors that mean certain data is shared. These are like, I'm not an expert in IFC, I use it for a living, I don't look at it all the time, so I had to look this up. So, type. Anybody want to know what type information means in an IFC file today? I know Thomas knows. Right back there. Yell it out. What does it mean?
The same type of window has one.
Okay, well, what data are we talking about?
Of windows?
Are we talking about p-sets? Are we talking about geometry?
All of them.
Are we? Always? I'm looking to the front row here for nods. I know a half answer because we also have map. What's map for? This is like the block definition of geometry. So this is actually how you separately repeat geometry in one way. So we actually have a very confusing collection that grew over time of different concepts of sharing data. So then we also have group, which is just a collection. I think this is the first time Thomas has ever seen that, so he might yell at me if I say anything wrong. So group doesn't place anything. Then we have, I think it's called an asset, which is just sort of like attic stock. Yeah, named group. Then we have inventory, which is the attic stock concept. So we have these things, but they're technically not placed. Then we have assembly. Assembly does actually allow for placement, and it doesn't apply to furniture. So the question is a good question, because what we think we need is one good way to decide, does it putting things together, like your question is basically two entities together, does it imply placement, or is it just a group? And we know, because we're operating in pieces, that it needs to be simpler to be able to say, does it provide location or not? And that's a separate property. But that we need to clean this up quite a bit. So I can't answer that question, but we know we need to simplify this in answering it. Because it could be we just need an assembly concept, just generically call it that provides location or not. And they could have different classifications that mean different things, but that might be the edge.
I think.
We'll get you a mic.
Thank you. I think this has to be sort of cleaned up, this with the type. We are looking at sort of having always geometry and properties on the type. But I have also looked at 1, 2, and 3D types that could be inheriting sort of, you have a wall thickness that is the, let's say, 1-dimensional type.
Yeah, so
And then you can inherit that characteristics to a wall that has height, the time, and then you can have the length, so that's some kind of element. So it's the same content on some kind of type level that you reference.
So-
and we are looking at, sometimes we let the geometry come to the sort of instance of the slab, but otherwise we could have an individual type for each of these slab configurations also.
yes.
So we are open for.
So if these are the final words, don't quote me on it, but we think we need 3 things, not 2. We need what you described as we've used the word prototype or archetype. Let's just call it archetype for time being, which is the collection of possible values. Then there's what we typically call a type, but because if you own fire rating on that wall, you don't own a type. You own typical data applied to those instances. And so we're starting to try to get people to say typical versus type, because type implies a lot, and it's, language is hard, and we all even speak different languages. So the idea that type means something different to everyone, and including here, it means a specific thing. And then we have, occurrence or instance data. We think we need those pieces. I think the last thing you're describing is something that we haven't even touched on, which is, I think, a geometric concept, which is actually, instead of having a typical layer set, I think is the way we would look at this today for a wall, that you actually have a wall that gets transformed into all the instances, which is a geometric concept that we haven't got to. But it's the most basic kind of reuse that people might want. I'm not saying, we solved that one now. Okay, so we're getting good validation on every one of these things, and remarkably, we've never found a room that these aren't the right things to talk about. What we need to do is get you to tell me what unique data relationships, combinations, and, I couldn't solve this problem and put data together in a certain way. Like the one, I'll give an example. We've discussed with Lars is on a product manufacturer today might model in a CAD software, a mechanical CAD software, and let's say they can produce some step data. So not IFC, but step. Today, what's being asked of design teams is they import that into their BIM tool, converting it from that native representation or model it from scratch. And then they export it again. Versus the idea that, well, actually, if I do this, why would I ever export it? I actually have the original representation, I just placed it. So I've moved myself around the CAD tool and just give the product a location by using the CAD tool. This is something we have to manifest in data by saying, I want a step file, I want to replace a pump, and I want it to show up on the other side without being touched, but I want it to be part of this sort of new collection of data. So what are the things that start to look like that we need to include in our sample data sets too? And the reason, a little bit more on top of this, the reason we need sample data sets is because to actually compare people's, let's say, the technical implementations of what IFC5 could look like, I need to be able to ask, how do you attach the information to the pump And it's this one we're talking about. When you do this abstractly, and we don't have a canonical data set that has all this stuff, it's very hard. That's the ask of the room. And all we need is examples. You don't have to solve it. There we go in the back.
Hello.
Hi.
In the current version of IFC 4x3, I'm playing around a lot lately with how to manage as-built information. So I have two ways of doing it. Let's say you have a bridge, and the surveyor goes and scans or measures with the Dataset station the bridge. You could take those points and represent them currently as IFC annotation and create a separate IFC file, which is only the points, and that's the as-built information. Or does the as-built information stay into the property set? In IFC 4x3, there's a common property set called set tolerance. Do you handle it there? Do you handle it with the points? How do you handle as-built information?
So this is actually a very meaningful topic. So one of the things, I'll just make an edit of this. One of the things, whether this name survives, but we're calling it location because it's more than transformation. But the idea that at least one bit of data that you have to have on a thing is this location. If you want it to exist in the world, it cannot have a location. That's certainly valid in this world. You could have all the data but have no idea where it is. That's a perfectly valid use case. But to your point, what we think we need to be able to do, and I think this is a group, so let me blow this up, is that why can't I? No, because I don't know how to use this keyboard. That what you're actually saying in doing that survey is you have a location survey. I'm just typing this in to say this. But this makes much more sense than having to say that I had a design location and now I have a new location, so it's a whole separate model. No, this is just a separate piece of data that describes this whole. What we're probably not going to get to in much detail here is how we actually ensure the design data is structured in such a way that this probably will come up more in the infra space, and this is this is where construction, we started to have this discussion. Construction is, you're halfway through design, right? So imagine you have let's say the alignment is starts on my left hand and it goes to here, and every one of my control points along the alignment, I'm replacing with survey data. So everything forward to the right hasn't been built yet. It's been designed but not built. So currently, we have to think about, well, should all the future points be related back to that survey location so that the design is a function going forward and still correct? Or what would happen today, roughly, is the second you override one of the locations along the alignment, I'm using locations very generically so we don't get caught in the semantics here. You're essentially invalidating all the future points that you have to adjust. So this is the kind of stuff that why having the construction as built and as designed at the same time is important, because these are the kind of things we're sort of missing if we don't capture this.
So what we are doing in our work is that we have sort of requirements. They are separated structured objects. They are linked to design objects. They are versioned. And then when you start construction, you link the construction representation of that thing. And that is then also version that can have multiple representations. And that means that you can sort of take action and see that the design, the planned design, or the actual design is valid for the coming points and then you can change the design, of course, if you want to adopt to the sort of changes or direction of what you have built.
Yeah,
So we have them as individual objects with their own links back to the design, and you can see the requirements on them.
So let me state, like, validate that this is the way you're doing it, or one would want to do exactly that. So design goes out, or design is done, that's version 1. You have construction changes that influence happens all the time. Go backwards into the design process that you make new changes to those new versions of those pieces of data that are now linked to new information on the construction. The same information, but new versions in the construction side. Yeah, I mean, this is this kind of stuff that is impossible in a ownership-based approach versus breaking ownership into pieces and then versioning things. Because, yeah, obviously the construction was based on version 1, but now future construction is based on version 2.
And 2 years ago, you talked a lot about
We have a good memory.
okay. About the USD. Is it also still a big part of the idea behind it?
So the question was asked previously about, but I want to make a reference to the question about multiple entities and then I'll come back to the USD one. So the one place we have not rolled out is that the construction entity and the design entity are actually 2 different entities versus sharing an entity. Linking them together is the same thing as saying they're the same, but you do have to have shared an ID before you can make the connections. We imagine things will happen. Design and construction is messy, so people will start before anybody gives them design information, so you might have to link them together in the future. So that would be the place that you might end up with, one door having 2 entities. That's very unimaginable, especially in the existing conditions. On the USD question, I think the place that it's coming out now in the more technical discussions about how we assemble typical data. Because USD is very much a scene graph sort of approach where this is conceptualized as less hierarchical. But what people are wondering is if our data looks hierarchical from a data assembly standpoint. So I could, like, if the top is the instance in my little hand waving exercise, and I want to attach some typical data here from an engineer and typical data here from an architect, and then I have sort of typical data that's shared across both, and then I get to the instance. That's a sort of reverse graph. That's the place people are interested in looking at it. There's a lot of stuff that USD does that we would want to avoid, like you can override from the top of the graph down. These are things we should not think about. Our data wants to be more controlled than that. So it's certainly making its way in. It's really, do we use a hierarchy for data assembly versus relationships, or more relationships, or relationships really just around linking foreign concepts together, like the control network in the door. Sorry, I didn't mean to point at the guys, but they're actually different entities. If you want to put them together and say they're a shared concept. Someone here? Who's got the mic over here?
Are you going to treat point clouds as step files or like external reference, as you mentioned before, or another form of decision about it?
There's no formal decision. I know no one is excited about putting point clouds in IFC, so that's not going to happen. I think that conceptually, what are we talking? Infra point clouds or building point clouds, like E57 or BLAS? Which one are we? Yeah, so like E57, conceptually, there's grouping concepts there. They're super slow, but the idea that you could just have a URI to that group to say, well, that's the window, conceptually makes a lot of sense. I think E57 development has sort of paused for the last couple of years, so there's not. That would be the most logical way to think about making these links, that I have an entity that's in the component system here. It's identified, so if you're browsing through this data, let's say, I know what it is. oh, it's the point cloud representation, but it's not stored here, it's there. But Tina was making the point about all the other data in the infra roadmap discussion. This is exactly how you would handle documents and everything else that describes this data, but isn't IFC, because this is just as important to the people, the customers of IFC as IFC itself. So how do you stitch this stuff together in a lightweight way? That's sort of how it's envisioned. And the same thing would go for the voxel discussion about underground and so forth. Oh, sorry.
Hello, I'm Maciej from the Romberg There's Array group, and I want to add one more perspective to that typization versus instantiation topic. So we place a lot of masks from the database as output data, and we need to choose sometimes. So, okay, what is the type and what is the instance for us? And I think it's highly steered by the manufacturers and also by the industry standard. So we have a mask that has specific width and depth, but the height is like 50 types or 50 values that are possible. And in Reddit language, we create one type, but we have instantiation of the height. So we are flexible and we don't have, it's like a balance between how many files in the folder you have versus how many folders you have. And I think that there is a need for flexibility in that topic because even different companies will always decide a bit differently depending how they use the library.
Yeah. So ignore the gray boxes in the middle, but the important part of this diagram is, so the bottom one is meant to be the building structure, the top one is the facade. So the top one, what you'll notice is everything at, this is basically the typical and entity. Left side is typical, right side is, instance, typical instance. So you notice that just the locations are on the right side for the facade. Think about that. They're highly repeatable. Oh, sorry, automations. They're highly repeatable, and so the only thing that's on the instance is the location, right? If the geometry is very similar, right? But on the bottom, where the geometry is different per, what you get is typical data is the material, and you get some of the geometry for the columns, but at the instance you say, well, actually, the location in the geometry is unique to each one, so they're part of the instance. So this is the point of being able to separate these two, that you choose based on your data how it's represented, and if it is all the same and it doesn't have a location, the only thing you'd have is some entity that says I exist as an instance. That's it. Yeah, right here.
Right. I'm just figuring out if you talk about versioning, do you would like to organize that in the data model? So I mean that you are using metadata on these entities and component sets, or is it something we should handle by the software tools?
So, as buildingSMART, we probably have to put more in the data than you would if you were building the tool. So I think the line is, and the discussion is really around how do we represent versions? Do we just come up with a common hashing procedure to say, oh, a hash represents the uniqueness, or do we need a component ID, entity ID, or entity ID, component ID, and component entity version, or component version, and that has its own ID versus a hash? That's the discussion I think that's happening right now, and it's really so. Like your example, you can point to a specific version. We shouldn't. I don't think we want to get into semantic versioning in the data, like naming these things. But unique identifiers is, I think, where the discussion is on each version of each component. Can I get a hand raise from the room, because this is a topic that gets a lot of discussion. Can I get a hand raise from the room that everybody that thinks they need unique version IDs on components? How about the people that have no idea if they should care? Okay, we got more than the other half saying yes. Do I get a no from anybody? No one. Devil's advocate, anybody that wants to come up with a reason why we shouldn't version components? Well, there we go.
No, I don't know. I'm just thinking like, if we think, like if you think about the analog to how software files are versioned, so like older versioning systems like CVS and whatnot, they were versioning files, but GitHub is versioning like
Hashes.
the whole repository. So that if we can get there, I think that would be like a better thing.
Yeah, so this is a conundrum. buildingSMART is probably not going to get in the software business.
Yeah, but if you can think, if you can manage the versions in the same way that every time there is a change, basically, that you commit, then there is a kind of new version of the whole project. If that's doable, but it might not be.
Yeah, so a lot of people do think that this is amenable to a Git-like workflow because these are much more closer to chunks of text than, I mean, don't visualize these as chunks of text, but they're small bits of data so you could easily think about versioning them. What is the challenge for doing this within buildingSMART is you could obviously track these totally outside of the data if we came with a spec for a database system or a data representation that itself tracks the versions. But if we don't do that, and I can email you a component, and you need to put it in your system and be able to say, oh, that's the new component, and I had the old one, then the data has to have this sort of richness in it. That's the sort of conundrum, if you will, as a standards organization versus a software approach. There's a question in the back. Just heard the recording, we got nods from the room. It's good to see nods. Not everybody nodded, but people nodded.
I want to play devil's advocate on the versions.
Good.
So maybe if you didn't need a version number, but would a user modified or last modified date be okay? Or like looking at how the phases work? Like I don't know if I need to know like a version number on each of those entities that changed, particularly if something had to change the number or if it updated, or if you had half the elements change on one model and then the next one half, another half, but it wasn't the same half that changed. How do you track that? Because lots of them would then be version 2. So I'm just wondering whether in a database we'd normally use like data modified. So I'm just thinking about maybe that's an alternative as well. Just like devil's advocate.
Yeah, so I think that the criteria that controls here is probably that not all modified data means it's final data, right? So the second version is still valid even though I have a third version, right? Like there's work in progress and maybe work in progress disappears in the future. So sequential stuff or sequentially thinking about this is probably not great. Yeah, no, it is how to do it without and let's be clear, some sort of unique identifier, not a user-defined semantic value, is what we've been describing as the thing we probably need to have and specify in the data.
Another one you mentioned was like the state of the data. So some bits of the model is work in progress, some of it you consider further on than that. How would we go about doing, specifying that and how that works?
Yeah, so what we have not really touched on is some of the larger concepts that are above that have to essentially replace a collection of data. So We assume this is transactional data, not live. Like there is a use case for a live connection between systems, but most of the time our data is, it gets work done, it's ready, here you go, here's the update. You need to be able to collect all that together and say, it's this version of that component, and it's that version of that component, collect it up, and here's all the IDs, and make a, send a packet of data somehow, either a web request or some sort of a container. We think that's what we have to support.
So, I don't know if I'm totally off here, but I would like to see the full history of the changes in entities. I want to have access to all previous versions. And as you said, each entity may have different owners connected to an item. If something is changed, that may have consequences for some other stakeholders. And they, if they're able, needs to see what has been the changes, and just as potentially have consequences for my entities or whatever I need to update. Because not everyone is changing at the same time. There are many stakeholders there, so that's why you need to be able to analyze the nature of the changes that has been done. And also if you think about life cycle, I want to be able to trace back to who changed what when and what was the consequence, because I want to send an invoice to that bloody fool. Sorry.
Yeah. So this is a very simple. This is an extension of the furniture example show, but this is basically just saying I've now, off of 2 applications, got my collection of components that describe these 9 chair entities. I think the text is actually white for some reason. I must have fixed this one. So to the point we're making here about change. So imagine the scenario where, okay, I had 2 applications, both produce geometry. It's this one's geometry I want. I am using very simple terms here, not specific ones. But then I have a transaction that I again work for an architect, so this is the world I live in, where I want to have a transaction with a contractor. I send them the entities plus those 3 components for each chair. Okay, so then they react to that and say, well, okay, I know the model, I know the quantity. I can do costing, right? This is a workflow. The interesting thing about this is really important aspect is I can think about doing this out of order and simultaneously, where I have to, today, it's not possible to necessarily do that. But to the point, that doesn't have to be a piece of software, but the idea is here, there's a change, right? What you need to be able to do is isolate those locations, transact those updates, right? And then, it's too late in the project, I can't use those locations, I need the 3rd. But to the point of like this kind of cycle, I think is what you're describing, which is basically, you couldn't do any of this if you didn't know which version of this data I had. Now, the only thing I will say is we're intentionally describing this as distributed. So as a client, you could mandate that everybody has to give you all your data. There's nothing in the system that requires all the data that the design team has, or the contractor, or whoever else has, to all be distributed, because it's intentionally small pieces of data. It could be that you only release, 8 of 10 data points to fulfill your contractual requirement, and the other 2 are for your benefit. Who knows? The system doesn't want to mandate either one of those. That's more of a contractual requirement. Here first, or do you have, and then we'll go there?
I think I know that versioning is very difficult, and we have engineering change proposals. So when it's important, you create new versions that are not sort of valid yet, and then you can do analysis of them and come back in sort of this control process outside, and then you select one, and then you have a new version there. And it means also that it's valid from that day. So there is an effectivity saying that this thing in that context is valid, but all the previous versions are kept in order after they were defined. So you have these processes, and to cascade the change from a low level higher up, that is done individually for any company.
Yeah.
Car manufacturer, they have all their own ways of saying that the Volvo is a new version, not when you change it, not on a wheel. So all these things have to be looked at really carefully.
Yeah, and I think it's important we specify what buildingSMART should do versus what software should do. What we need to make certain is individual versions can be identified. Software needs to do the management of those versions, right? We're not designing a version management system. It's simply saying that what is the minimum data we need to be able to uniquely identify it, especially if you're not like the reason for a system like this having to exist is not everybody's software systems talk to each other. Like on the main stage, the example from Ferrovia was 4 CDEs on the same project, right? I think that was referenced yesterday. So the point is, the identification is the important part. How the actual versions are stored and transacted and all that stuff, that's the software problem. Identification is the thing we need to handle. Mike's there first, and we'll go here.
Do you think that for an object there's never a full version because it's always incomplete? It's only the collection of component versions?
Yeah, this is what files are actually really good at, right? They're all this the same thing, right? And I think that's probably what you end up thinking about is like a named collection means that everything of individual different versions inside of it is represented as a whole, I think. There's actually, let's go here and then down.
And did you also think about how you can prevent that data gets lost? So although it's a very small component, but how can you be sure that one component which has been transferred to someone, if you use it again, that's one component has been lost or something?
Well, I think this is where we would just rely on, you could do all kinds of things to say, hash the collection of components or something like this. I don't think we have to touch making sure you get the same data one side or the other. That's a solved problem. You can do that in several ways. So I think we're trying to, as much as possible, only do what's necessary to solve this distributed component problem and not add more layers of design on top of it that we don't need to.
Right, so I was gonna say, one of the biggest issues we're gonna have with the distributed component system, related to the previous comment, is that there's never any guarantee of consistency. Right, so if you go back to your picture of the chairs and the desk, just taking the most trivial example on the planet, someone can move one of those chairs and move it into the desk, right? And that's a perfectly valid distributed thing to do. But of course, that's not a valid thing in reality. Right? The chair can't be inside the desk. So kind of independent of anything we're talking about here, that there will have to be ways that some systems will tie into this and say, okay, something's changed. Is there a problem that needs to be resolved now? Right, so if system A owns the chair and system B owns the desk, still system B might want to look to see where the chair is now and decide to pop up a message and say, by the way, there's conflict here, you're gonna have to resolve it.
Yeah, and this is where any of these, like, once we get a level above this and say, we want to send some data somewhere, I think you quickly run into basically 3 modes, we think. You have one-off transaction. I'm just gonna send you this data, you never look again, right? It's like a file exchange. And this is really much more API design than anything else. There's, I get continuous access, but I can't ask for new data, I can only ask for the version that I was given. And then I get updates or latest access, right? So that would be how you have to structure either generally either side of that transaction. But then clearly in a, this definitely moves over time to a standard API that sits on top of this, and those are the sort of things you'd include in there, because then I could subscribe to updates and know there's an update that makes me need to change. And that, we don't need to decide if that's a piece of software, if it's a web service, whatever. It's just a subscriber.
Right, and we probably should have some set of guidelines or APIs around that. That what happens beyond that, of course, is beyond the scope of anything we're talking about here, right?
Yeah, like what you do with updates, it's your responsibility entirely. Well, good. Wait, I was gonna suggest if we have no other points or people don't want to suggest new updates to our test data set, we can just keep going, but yeah, please.
Maybe one more question. What's the roadmap for IFC 5?
When we get there.
All right.
I think we're all quite comfortable with the requirements, like everything we've been discussing has been talked about pretty good. We're comfortable with the unit of data being a component. I think the things that we need to get through by, I think we want to get through by Morocco definitely is, okay, here's how you model it, model the typical data all the way up, and here's how it looked like. And oh, by the way, here's our example data set starting to be in at least the best candidates for how to do that. I think that's the goal we have for over the summer. The other piece that is another bit of effort that we're just discussing is cleanup. So IFC has a lot of concepts in it that don't look like this. There's like the object inheritance and everything inherits from root and stuff like that. But this is very much not an object model based approach. So there's other kinds of efforts that would have to take place, like what we discussed in Oslo is like attributes just become property sets. But there's some maintenance discussions. It's really, this is certainly my opinion, I don't think buildingSMART would say this, that a lot of the inheritance that exists in buildingSMART is certainly useful from a maintenance of the standard, because a lot of things do look the same. But what we're describing is not nearly as canonical. And so like, oh, this collection of 5 components, that's a standard wall archetype as described by buildingSMART. That's, it's a collection of a kind of geometry, a set of properties, how they're located and how they're constructed, as example. So there's that kind of work that is, I would say, very much aligned but tangential. I think the discussions that are, let's just call them active in the last couple of days or even just today, is to do what we're describing here with the unit component system, and do you go to a file approach first, or do we make a simplified version of 4x IFC first? These are discussions that we need to get a bunch of people in the room to hash out.
Yeah, it's also a little bit it's also a little bit my impression from the discussion that there are so many topics coming up from different perspectives, like versioning, componentization, more like an API view on the data. On the other hand, it's simplification of IFC, maybe getting rid of some of the legacy, which is in the current data model. So for me, maybe it's not a good idea to put everything onto a single label and a single approach. Maybe you have to split it into more parallel developments. I think there's not a single answer to all these questions that came up in the room.
Yeah, I mean, IFC 5 was the name somebody gave this project instead of this next version of IFC, right? So these are not. It would be, one of the questions is, okay, let's say we have two paths, and this is not you're not voting for the direction, you're just voting for, try to think through this a little bit. One path is we have a simplified version of this component-based approach, but it's still represented files, and it sort of could even be like a zip file that inside of it looks like this, as example. I'm not saying I agree with that approach, but it's files, but takes on this new architecture, not an API yet. But if I send it to you, you can do all the things you talked about, but it's not behind an API. There's still, you use a CDE, the CDE cracks open the data set. Oh, I have these new versions, I can compare them. Here we go. That's one path forward. The other is, we make a model, we take IFC as it is today, simplify it, do the modernization, but we still get a singular file. So less of the exchanges, but simplified. And then we have a separate API project after either one of those. Just to give you my personal, because I'm a customer of buildingSMART in the context that I work for an architecture firm. The one that's more important to me is the componentization, so I can distribute ownership quicker. The API, that can come second. Having a monolithic file is a problem. So that's not buildingSMART, but as a customer of IFC, that would be more important to me. So who thinks they look more like the distributed ownership part? API can come second, can't. Raise your hand. Opposite side, simplified singular file. Well, because we assume API comes second in either scenario. It's just which one of these do we do first? Do we make a component thing that looks like a single file, or things that looks like multiple files, but inside of it's really just the components?
It could be even like a folder structure.
Yeah, it could be a folder structure.
Yeah, like first, and I think it would be better to have the components represented as separate file, so that we are not trying to bundle them into one file, so that we are kind of clear from the beginning.
Maybe it's also a question, what do we understand about file? I mean,
but everything's filed at some level.
Yeah,
So.
I mean, it could be still a single data stream, which is a component that can have individual access to the different parts within. This idea was also quite old with, I think it was the typical file class 3, that you can have actually a bunch of files and a kind of header directory.
Yeah, it's really
that gives you access to.
And I think what we're saying about one file with a bunch of stuff inside of it versus a bunch of little files is distributed ownership.
Yeah, so the question was a file.
Yeah.
I mean, we can start with like folder file structure and then iterate. Like we need to start from somewhere.
Yep.
Yeah.
Yeah, I mean, again, if you think of it as an IFC zip, where, right, each file is a component, period. That's it, right? And this is the ID, and this is the data there, and then you could piece it back together, right? It's still, in the end, you could create a step equivalent.
Yeah.
If you wanted, right?
Yeah, it's always easier.
The idea to have a little like a directory file that tells you what the components are.
We don't need to get stuck into this, like, we can start with the simplest one and then come. Yeah. Start with the simplest things that the operating systems give us, like files and folders. We can start from there. And then if we want to improve it for some reason, then we can come to something else.
Right. So we're 10 minutes left. Anybody have open questions? So tomorrow is more of a wide-ranging topic. What I'm gonna, just so you can decide to come or not. the first place we think we're gonna start is step for geometry. Perfect, let's not change it. Let's keep it our version of step the way it is. That's not something we need to touch. There's a longer term discussion about, is that the only representation we should have? And I think in the context of sort of large language models and stuff like that, there's a case to sort of even think about more diverse, more novel, let's say, representation. So we wanted to have this discussion. We haven't done IFC 5 yet, so we should take advantage of the fact that, you can, I'll show examples of teaching a large language model how to model geometry because it looks like language should we take these things into consideration? So it's a more open session. I'm not gonna try to tell you anything tomorrow. I'm gonna show you some stuff and hopefully elicit some conversations. Okay? Thank you all.
Thank you, Rep. Thank you, everyone, for attending, and looking forward to seeing you at other sessions of the summit.